Hello, friends. Jim here with Science Talk. Okay, now to discuss what the potential cost of the Arctic melting could mean. You present science to politicians, most of them, and they're like, la, 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 la. They ignore it. They don't listen to scientists. It's not until you start putting things in economic terms does it get their attention. And basically, I have reports here from several journals to share with you, but what the conclusion that's being arrived at is that the fast melting Arctic could end up costing 70 trillion with a T, dollars. Now, I've done previous video segments where I mentioned how, as the permafrost thaws, the roads, the buildings, basically the infrastructure starts crumbling, literally sinking into the ground, causing great damage. So that's part of it. There's more. Right? We already know that the Arctic is warming twice as fast as the planetary average. Okay? We know that the carbon is being released from the Arctic, from the ground. There is also reduced albedo. Sea ice is disappearing. Look at what I discussed recently with happening off of Alaska in the Chukchi Sea. Right? Open waters. No, it's going to absorb all that sun energy. And now it's releasing that energy, latent heat energy, keeping the air warmer and giving us more precipitation. So, that's some of the ramifications we've already seen. And that's some of the factors leading to, the situation at hand, namely increasing temperatures. Remember, snow, ice is white, reflects sun energy back to space, cooling planet. Reduce snow, reduce ice. Now the Arctic absorbs that heat. One of the reasons why it's warming faster than any other region. The concern is what scientists refer to as non-linear transitions. Now, you've heard me say before that when the melt rates, the thawing rates, the melt rates of Greenland ice, the thaw rates of the permafrost has been underestimated, it's because usually they're assuming a linear progression or linear continuation. Nonlinear means it's nonlinear, which means it's usually going to be exponential. So the concern now is that as the snow and ice disappear, the warming is going to be faster. And that will send the planet into a new climate regime that will be irreversible. In other words, a tipping point. And there are those who are of the opinion we've already passed that tipping point. I'm one of those, to be fair and to be upfront. So, this is going to disrupt climate. This is going to create heat waves. This is going to raise sea levels. It's going to give you drought, harvest failures. What harvest is cultivated will be less nutritional. And I've done video segments discussing those aspects. Storms will be more violent, more devastating floods, more devastating fires, etc., etc. So we have a report in the journal Nature Communications that if the nations of the world were to be able to keep the promise in Paris to keeping the warming to below 2 degrees C, ain't gonna happen, then the extra cost of Arctic ice loss would still be over $24 trillion. Not 70, but 24 trillion if you can keep it a 2C. That ain't bloody happening, to be blunt. But that's what they're reporting. So I report to you what they report. But on the evidence of national plans so far, the world seems on course to hit 3 degrees C by century's end. That's if humans are lucky. It's probably going to be 4 or 5. I'm actually now seeing 5 degrees C by 2100. I think we're on pace to hit 3 degrees C by 2050, looking at some of the models that I'm seeing. And then if that were the case, then that's when we start hitting the $70 trillion mark, which, to be quite honest, is probably a low-ball estimate. If the world continues burning fossil fuels, no, everything's fine, business as usual, then global temperatures could rise to 4 degrees above the historic average by 2100, some cases 5 degrees C, according to some models. And then if that were the case, then the cost would be $2,197 trillion. They also stress the fact that the forecast of $70 trillion is just the extra cost of the melting Arctic. This is the Arctic, not counting the rest of the world. They have not factored in all the other much feared potential tipping points, such as loss of tropical rainforests. Right? Tropical rainforests absorb a lot of the atmospheric carbon. Well, you got Bolsonaro going nuts there in the Amazon, cutting down the whole damn forest, so now that's going to create more carbon source into the atmosphere. Or, and I've discussed this numerous times, the collapse of AMOC, the conveyor belt, right? Atlantic Meridional Overturn Circulation, which takes equatorial heat, brings it to the polar regions, takes polar coolness, brings it to the equatorial regions. The loss of the West Antarctic ice sheet. Right? Even to contain global warming to 1.5 degrees C by 2100 would cost a global $600 trillion. Okay, that's global, not Arctic. Well, we're already at 1.3, and we're not going to keep it at 1.5. This is almost a moot point. So how do they come up with these estimates? Modeling, right? No, the calculation costs are estimates. So let's be upfront and say and mention that there are estimates, and there are estimates based on the observations in nature from the warming, as well as, once the models are good, the extrapolations of said models, and then you try and do the economics based on that. I'm not an economist, so I can't. That's not my area of calculations and so forth. I dealt with differential equations and flow rates and that kind of stuff. Researchers in California report in the Proceedings of the National Academy of Sciences that they've now reconstructed change in the Greenland ice sheet between 1972 and 2018 to estimate the loss of ice. Okay, so they've gone back, look at the data, recreate the model that recreates that observations faithfully. 50 years ago, the Northern Hemisphere's greatest sheet of ice was losing 47 billion tons of ice every year, and by the next decade, 50 billion tons annually. Since then, the losses have been almost sixfold, and since 2010, Greenland's been losing ice at the rate of 290 billion tons a year. So we've gone from, let's just say 50 to 290, nearly a sixfold increase. If you go at 47, it's pretty much a sixfold increase. Ice from Greenland alone has raised sea levels by almost 14 millimeters. Now, 14 millimeters, you're going to say big whoop. That's, that's basically 1.5 centimeters. BFD. That's worldwide sea levels, folks. That's a shitload of water. To be blunt. That's just Greenland, not even Antarctica. German scientists have looked at the results of 15 years of observations by the GRACE satellite system. Now, GRACE is an acronym for Gravity, Recovery, and Climate Experiment, GRACE. Now, this program did end in 2018, but they calculate that between April 2002 and June 2017, Greenland lost about 260 billion tons of ice each year, and Antarctica 140 billion tons. Interesting, Greenland lost more. They present their findings in the journal Nature Climate Change, and they warn that melting at this rate could accelerate sea level rise to 10 millimeters a year. Now, to put it in perspective for folks who are not familiar with the metric system, 2.5 centimeters approximately equals 1 inch. So 10 millimeters a year is 1 centimeter. So we're basically talking a fifth of an inch. Okay? That's faster. This rate is faster than any time in the last 5,000 years. This is a direct consequence of a warming climate. So 1 centimeter a year. The traffic of sea ice across the Arctic Ocean has begun to falter, according to German oceanographers. Okay? Traffic of sea ice. Right? So the movement of sea ice is faltering. The transpolar drift is a slow flow of new sea ice from the Siberian Arctic across the pole to the Fram Strait, which is just east of Greenland. Okay? Now, the transpolar drift was discovered as a result of an 1893 Norwegian exploration that included the explorer Fridtjof Nansen, when he deliberately put his ship, the Fram, into the ice pack off Siberia and went with the flows. Okay, I couldn't resist the pun. Okay, so that's what, now we know where we get the term Fram Strait, because it's in honor of Nansen's vessel, the Fram. In fact, there's a whole bunch, for example, when we want to collect a water sample at depth, we use a Nansen bottle. So that's what he was doing. It's basically a tube, and it has a couple, enclosures on a spring level, set aside. You set it down to whatever depth you wish to collect the sample from. Then you send down a messenger, basically a big heavy weight. As it slides down the cable, it trips the catch, and the ends then close, sealing a specimen at that depth. You get your sample. Simple design, but ingenious. And then you can say, you can run whatever test you want, biological, chemical, what have you. So this drift, the transpolar drift, is basically like a conveyor. It's a frozen conveyor that brings nutrients with it, algae, sediments, that kind of stuff, across the pole. Researchers say in the journal Scientific Reports, this flow has started to vary. Most of the young ice off the Siberian coast now melts before it can leave this area where it first froze up. Once half the ice on the Russian shelf completed the journey, now only 1/5 does. Now, this is even taking into account the Arctic Oscillation and the Arctic Dipole. I did a video series on the oscillatory system of Earth. One of them is the Arctic Dipole, which, depending on if it's a negative positive phase, will either keep the ice within the Arctic Ocean or help move it out the Fram Strait. If you have not seen those videos, please check them out. I think you'll find them informative. So Thomas Krumpen of the Alfred Wegener Institute, who is the lead, the principal investigator, states, what we are witnessing is a major transport current faltering, which is bringing the world one step closer to a sea ice-free summer in the Arctic. The Chukchi Sea is slated to be seasonally ice-free as it is already. The ice now leaving the Arctic through the Fram Strait is on average 30% thinner than it was 15 years ago. So, you have heard me say that if you can sum up overall in bullet points, general bullet points, what's going on with the sea ice, it's as follows. Freezes later in the year, melts earlier in the year, not as thick, less and less, which means less and less multi-year ice. The southern extent isn't as far as south as it used to be. And we're collecting more and more data that backs, when we state these major bullet points, because the data that's been collected. So things are changing, and it's definitely due to humans. This is the data that shows all that's happening. And with that, with the loss of sea ice, the Arctic absorbs more and more heat that warms up the planet. And from that, you get all the other things that are going on. Not a good situation, at least not for humans. Thank you for your time. Hey folks, this is Jim here reminding you to please subscribe to my channel and please share my videos with others. Also remember to click the bell so that you know when I drop in a new video. I also ask that you please consider becoming a patron of my channel and support the work that I do by going to patreon.com/Science Talk with Jim Massa, each word separated by an underscore, and becoming a patron. It's asking for as little as $3 a month, cost of a cup of coffee, to support the work I do and keep my informative videos coming your way. Thank you for your support.